Professor Rad here, and today we're going to analyze a conic section. In the last video, we did an example of analyzing a conic section that was not in one of the three forms to begin with, so it wasn't a perfect parabola, ellipse, or hyperbola format, but it was really easy to get into that format. In this example, we're starting with a little bit of a messier equation. So this problem is going to involve us completing the square. So we'll review that a little bit. And so let's just go ahead and get started. So I notice here that we've got a y squared in the equation, which is good. But there is no x squared. So we have also a y, and we have an x and a constant value, but there's no x squared. So as soon as I see that only one of the variables has a squaring to it instead of both of them, that means this is going to be a parabola. So I can identify the type of conic section from that. If I had both an x squared and a y squared in my equation somewhere, then that means it's going to be an ellipse or a hyperbola. So this one I know already it's going to be a parabola. So let's get it into one of the appropriate parabolic forms. So to do that, the parabola form, remember, has something squared equals either a positive or a negative 4a times something, right? So in this case, we know that we're going to have the y stuff being squared, and then the x stuff is going to be over here. And again, I know it's going to be the y stuff because we have y squared. So this is the shape that I want to rewrite this equation into. So notice that means I need all of the y variables on one side, and then everything else has to be on the other side, since this is where like the x value is going to be. So to begin with, I'm going to keep anything that has a y attached to it on the left, and I'm going to move everything else over to the other side. So I'm going to subtract 6x, and then I'll subtract 6. Cool. So my first goal now then is to get that perfect square on the left-hand side. So remember to complete the square. You take half of the b coefficient, right? So half of 6 is 3, and then you square that to get 9. So 9 is the magic number that we're going to be adding to both sides of this equation. Negative 6 plus 9 is a plus 3. I should also mention that this works because the leading coefficient of the y squared is a 1. If there was like a 2y squared here, I'd want to divide through by 2 or factor out a 2 before completing the square. But since our leading coefficient here is a 1, it's the easy kind of completing the square. Just divide this by 2 and square it, and that's what we'll add to both sides. That means now on the left-hand side, we have y plus 3 squared. And just to track my work a little bit better, I'm going to write it this way. Right, so I added 9 to both sides. And now I can do that simplifying on the right. So that's where that plus 3 had come from. All right, cool. Left-hand side all set. Right-hand side now needs some work. So remember, on the right-hand side, it was 4a times something, either a positive or a negative 4a times something. So that something is x minus h. So what I want to have, my goal right now, is to get a leading coefficient for the x to be 1. So that means whatever the coefficient of the x is what I'm going to factor out on the right-hand side. So I'm going to factor out a negative 6. That's going to give me x minus a half. And I like to distribute just to make sure I didn't make a mistake. So negative 6 times x is negative 6x. Negative 6 times a negative 1/2 will give me a positive 3. Cool. So then the next part I want to do to get this into one of the nice parabola forms is I need 4 times something here. So now I'm going to take this negative 6 and I'm going to factor a negative 4 out of that, since I know a has to be positive since it's a distance. So I'm going to factor a negative 4 out of that. And essentially what that amounts to is taking 6 and dividing it by 4. So if I want to check that piece, 4 times 6/4, the 4's cancel out, and I would just get that 6 back again. So perfect. And then, in fact, I'm going to simplify this because 2 goes in there 3 times and twice. So this is going to be the format of my equation that I'm going to want to use. I have something being squared equals to, in this case, a -4. Since we had a -6 before, we have a -4 times a times something else. All right, so now I can figure out some more of these components. In fact, since I'm a parabola, I only have one focus and I only have one vertex. There's no center of a parabola. And then I don't need any of these other axes that come with other conics. And there's no B or C, just an A. So for my parabola, let's see. So because the y part is being squared, that means this is going to be a sideways parabola. So remember, if y is being squared, you get a sideways parabola. And since it's a -4, that means it's going to be opening towards the left. So I might just leave myself a note that it's going to open to the left. And in the formula of a parabola, we have the vertex. So if it's an ellipse or a hyperbola, we have the center, but here we have the vertex is going to be a +1/2 and a -3. Remember, the signs are different. So the vertex is going to be 1/2. Comma a -3. And I know that A is going to be 3/2. Oops, since we figured out A here. So A will be 3/2. Now, the rest of this stuff, if you memorize the formulas for these based on the format of the parabola, then you can also figure these values out now that we have the vertex and A. However, I'm going to jump to the graph now and start plotting some stuff. So my vertex is 1/2 -3. So that's where I'm going to plot that. So 1/2 -3 is going to be down here. There's my vertex. And then I know that I'm going to be opening left, as we had mentioned before. So since it's opening left, that means the focus is going to be to the left of the vertex, and the directrix will be to the right. So my distance of A is 1/2 or 3/2. So to plot the focus, I'm going to go, here's 1/2 and then 1. So that's a distance of 1/2 to the left. And then the directrix is going to be a vertical line 1.5 units to the right. Remember, the vertex is halfway between the focus and the directrix. So, okay, oops. I've got too many menus popping up here for recording here. Okay. Right, and so this is going to be 1/2 and then 1. All right, so now we have these components. Once you have these in place, you can also graph the axis of symmetry and the latus rectum. So my axis of symmetry is going to pop in here. Remember, the axis of symmetry runs through the important components, so it's going to run through the vertex and the focus. And actually, before I graph the latus rectum, let's write down these coordinates of things so that I have them in place. So the focus is going to be at -1, -3. So let's go ahead and write that in. Sorry if you heard that noise. My cat is jumping around things now. So we have our focus at -1, -3. And the directrix is a vertical line and it runs through 2. So the directrix is going to be, vertical line is x equals 2. And our axis of symmetry is a horizontal line, so it's going to be y equals, and in this case, it's equal to -3. Nice. Lastly, for the latus rectum, this is going to be parallel to the directrix, and it runs through the focus. Remember, the latus rectum is how we're going to get 2 additional points to plot on our parabola. So we can go ahead and graph this here. If it will be a vertical line here today. There we go. And then the way that you get those 2 additional points is you take the value of A and you double it. And that tells you how far along the latus rectum you need to move to plot those points. So since A is 3 halves, if I multiply that by 2, I get 3. So I'm going to go a distance of 3 units up. So we have 1, 2, 3. Around here. Okay, Lenny is jumping around on things again. Perfect. And then we're going to go down 1, 2, 3. So these are the 2 additional points. And if you want to do a double check, remember they should be equidistant from the focus as they are from the directrix. So we have 1, 2, 3 units here and 1, 2, 3 units here. Okay, so that's how we know we've plotted them correctly. So then I'm going to take my little start of a parabola-ish here. And let's see, it's going to run through my vertex and these 2 other points. And again, I'm sort of limited by the capabilities of Word, but if I were graphing this with my pencil or pen or paper, I would make sure to extend that parabola. But if I try to do that here, it's going to just create a circle because of how it's being generated. So remember to extend the graph, do as I say, not as I do, I guess, through the whole graph. Yeah, so is that all the pieces here? Oh, I got to write the equation for the latus rectum. That runs through -1 here. And it's a vertical line, so it's going to be of the format x equals -1. All right, so we've got all of the components of the parabola. We have the graph, so there we go. That's how we have analyzed this conic section. So in the, I would say this is sort of like a medium level analysis of difficulty. The last example we did was probably a low level analysis. The next example that we're going to do is a more challenging example. So it will also involve completing the square. And remember, on this one, we had a leading coefficient of 1, so completing the square wasn't too bad. In the next example, we'll have to complete the square with a non-1 coefficient. So it'll be a little bit more challenging completing of the square to work through. Yeah. What's most challenging about this one, I would actually say, is the fact that it's a parabola. So when you have either both the x and the y being squared, it's a little bit easier to work through it because you know you want to have, basically everything with the variable over here and everything without over there. So the key for a parabola is once you notice one of the variables is not being squared, you want to get the squared variable family over here. So since the y was being squared, anything with a y stayed on the left, and then everything else goes to the other side. So that's the key when analyzing a parabola at the beginning. All right, yeah, so I think that's going to wrap this up here. I'm going to stop babbling now. And in the next video, we will, as I mentioned, do one more example of analyzing a conic section. So I hope you found this video helpful, and I also hope that you have a wonderful day, and I'll see you next time. Bye for now.